Hello, welcome to Intro to Probability. Okay, so the first and most basic question is what actually is probability? Well, probability is how likely an event is to happen. We've used the sort of words based around this for ages. It's not very likely that I will, knock all the pins over when bowling. It's very likely that a professional will. Okay, but we don't want to just be able to say it that way. We want to actually start using maths to go, well, it's exactly this likely. Okay, so probability is how likely something is to happen. Something is to happen. So we need to have a range of numbers. Okay. So what we do is we put in the range from 0 to 1. Okay, so that is our range. It goes from 0 to 1. 0 is impossible. Okay, I can never jump and get to the moon. That's impossible. That could never ever happen. So there's a probability of zero of me jumping and getting to the moon. And 1 is certain. It will always happen. If I flip a coin, going to get heads or tails. Okay, in theory you can land on its side, but we'll ignore that. Okay, so that is the setup of the maths for probability. So now we need to start dealing with the language. So in language we have three important words: trial, outcome, and event. So let's say that we're rolling a dice. Well, that's the trial. Okay, so it is what we are doing to get our numbers. It is the activity or experiment. Right? The outcome are the results. So I'm rolling a dice. My outcomes could be 1, 2, 3, 4, 5, 6. They are all the possible different things I could get. Okay? And an event is one or more of the outcomes. So, for example, rolling an even number would be an event. Okay, one or more outcomes. Now, there's an important bit of language here. If I want to say, what is the probability of rolling an even? I write P, the probability, even. Okay? And in this case, getting an even number, rolling a fair dice, fair meaning that every side has an equal chance of happening, getting a half. Okay? The probability of rolling a 6 is 1 in 6, etc. So this is the language, so don't get confused by it. Right. Estimating probability. So if I've got a bag with stones in it, different coloured stones, okay, and I pull out 50 stones and I find that 20 of them are red, I want to go, what's the probability of me drawing a red stone? Okay, and for that we get the relative probability. Okay, so the relative frequency even, sorry. So relative frequency equals number of trials that we wanted, so useful ones, over total number. Of trials. So in our case, we had 20 reds, and we rolled 50 times, so it's 2/5. And this is an estimate for our probability, of our true probability. Okay, I might have drawn 21 or 19. Theoretically, that can happen. Okay, and the more times I draw these out add the numbers up to see how many I've got, looking at the relative frequencies, the closer to true I will get. I could draw out five of these stones, placing each time, and get no reds. That doesn't mean there's a 0 chance of it happening, right? But if I drew out 5 million times, you'd be very, very surprised if I got no reds, assuming there were actually reds in there. Okay? So what we actually mean by this then is that our probability here is getting closer and closer to the true probability. This is our probability we're getting. It's getting closer and closer to the theoretical as we increase the number of trials. Right? The next thing we can do from this, once we've got our probability, is work out how many times will something happen. So I've worked out that I've got about a 2/5 probability, or I could have actually gone into the bag and counted how many reds there were, and seen how many we should get, right? What fraction of our actual number of beads were red, right? That would be our theoretical probability versus our estimated probability, which comes from relative frequency. And from that, I'm able to work out, okay, well, if I roll the dice, I don't know, 40 times, not draw the dice, sorry, draw 40 different beads, okay? How many should I get? This is called the expected frequency. And that equals the number of trials times by the probability of the event. So for a moment, let's assume that we're going to use that as a probability of getting a red, and I'm going to put that in probability of red. And I want to know the number of red if I draw 40. Okay, so this is my expected frequency. So it's going to be the number of trials, 40, times the probability of an event, 2/5, right? And that equals 16. So that means I would expect to get 16 different reds coming out. Okay. Now, that doesn't mean that I will always get 16, but it means that that's what I would be thinking that I would get. Okay. So if I got 3, I think that's a bit weird. And if I got 39, again, I think that's a bit weird. Note, with an expected frequency, you can actually get a fractional answer. So what you have to do then is you have to round it, okay, to the nearest whole number, because you can't get like 15.5. So if this had come out as 15.5, we would have said, all right, well, that means we expect to get 16 reds. Okay? Okay. On to the last step. Mutually exclusive. All right. Mutually means they are both. Exclusive means that they exclude each other. So if the first, so let's say we have 2 events. We have event A and event B. Right? Just naming them. Event A and event B. If they're mutually exclusive, that means that if A happens, B cannot. Okay, so let's say I'm rolling a dice. Event A is get an even. And event B is get a 3. You can see that if I roll a dice and I know I've got a 3, I definitely haven't got an even number. And if I roll a dice and I know I've got an even and I definitely haven't got a 3, if I get 1, it excludes the other. So if I get A, it excludes B. If I get B, it excludes A. They are mutually exclusive. They exclude each other from happening. Okay? I could have another one where I have event C and D. Event C is odd, getting an odd. Event D is getting an even. They are also mutually exclusive. Okay? So that's all it means. Now, the probabilities always add up to 1. So, if the probability of getting a probability of getting 3 is, let's say we don't have a fair dice, is, I don't know, 1/5. What's the probability of me not getting a 3? Well, it's everything else. Of not 3 is 1 minus 1/5, or 4/5. Okay? So I'll either get a 3 or I won't get a 3. Okay? And if we write that in notation, this is probability of B, because if you remember up here, probability of B is getting a 3. This is the probability of B with a little dash. That means not B. Okay? Now, we bring in an extra word here, which is exhaustive. Now, don't get this mixed up with exclusive. It's completely different. Exhaustive means that you have exhausted everything. So you have found every possible solution. So if you have an exhaustive list, that means you have listed every possible way things could go. I roll a dice, I could get a 1, a 2, a 3, a 4, a 5, or a 6, right? That is an exhaustive list. If two different probabilities are exhaustive, that means that those two probabilities will give you every possible way that something could happen. Okay? So that means that if two sets of mutually exclusive events are also exhaustive, then their probabilities will sum to 1. Example of that would be what we've just done here. Probability of getting a 3, probability of not getting a 3. Well, it can't be both a 3 and not a 3, so they're definitely mutually exclusive. And it's every possible way of getting it. Okay? But just because something is exhaustive doesn't mean that it must be mutually exclusive. I could have the probability that we are bigger than or equal to 3, and the probability that we are smaller than or equal to 3. Okay? Those two events are exhaustive. They hit everything. But they're not mutually exclusive, so you can't just add those probabilities of them together to get 1, because they both include the probability of getting a 3. Okay? Right. That is the end of the introduction, and you might want to go and have a play with a few questions now.